In this video I want to explain about the LALR table. In the previous video we already discussed about the CLR table for one grammar example. Now for the same grammar example, let us consider this LALR table. So here LALR table is completely depends upon CLR table only. By using the CLR table we need to apply some kind of rules, and the rules will give a resultant table. The table is a LALR table. So what are the rules we need to apply here? So let us go to here. To construct the LALR table we need to identify the states which are having similar items but different locates. Then what do you mean of this statement? What do you mean of this statement? Let us go here. Now here the few states like I4 and I11, there the respective state items are similar. L derived dot star R, and here also dot star R, and even the place of dot also in a same position. So approximately they are similar but their locates are different. So we need to identify the such kind of states. Those are item sets are similar and locates are different. So such kind of item set we need to identify in this canonical form, and after that we need to apply the union using CLR table. So we need to identify such kind of states and apply the union between them using CLR table. Let us discuss in the next slide how we are apply the union. In case of no similar item set is there in that LR1 canonical form, then what we need to do? Nothing to apply the union. In case of there is a chance to apply the union, then you apply nothing, but you maybe identify the similar kind of items item sets, so you need to apply the union. Otherwise you no need to apply. Then the CLR table also become a LALR table. In case of the so let us consider there are two states are identified. In case you are when you are applying the union, there may be a chance to get shift to reduce and reduce conflict. So whenever you are applying the union operation, you may not be get the shift to reduce and reduce conflict, then it is called as a LALR table. But whenever you are applying the union, there may be a chance to get the shift to reduce and reduce conflict, then the grammar is not a LALR. In case of no shift to reduce and reduce conflict in while you are applying the union, then it is called as LALR. So that is the difference we need to identify. Whenever there is a CLR, the grammar may be passed by the CLR, we cannot say that grammar will also become a LALR table. See here, if the grammar is not CLR, of course the grammar is CLR is a more powerful than LALR. If the grammar is not CLR, how do you say if the grammar how do you say that the grammar is not CLR? Based on the conflict situation. In case of while you are construct the CLR table, there may be might be see that shift to reduce and reduce conflict, then you say that that grammar is not a CLR. If at all it is not CLR, then obviously it is not becoming a LALR. That is the meaning you must be remember, because CLR is a more powerful than LALR. In case even the grammar is a CLR, but it may not become a LALR. So because it is a CLR, and the next stage you want to construct by using this table, you want to construct the LALR. While you are applying the union operation, there may be a chance to get the shift to reduce and reduce conflict, so that every grammar of a CLR may not become a LALR. So whenever it is becoming LALR, after even you are apply the union operation, in case there is no shift to reduce and reduce conflict, then you can say that it is a LALR. So these are the rules we must be remember. Let us go to the let us go to the canonical form, how we need to apply the union operation. See here, these table already we have constructed in a previous video, CLR table. So here the steps. So this is the canonical form. We already constructed in a previous video. What are the things we need to identify? We need to identify the states, their production or items are similar, and there maybe their locates are different. So such kind of states we need to identify. So there we can, whenever you go through this canonical form, I4 and I11 are obviously they are similar item set as well. L derive ID, and here also L derive ID, but locate is different. Here locates are different. So such kind of things we need to identify. What are the who are similar? So I4 and I11 similar. Locates are different, so that let us give the state number as a I411 to remember easily, to give a new name as a I411. Next, who are another state? I5 and I12. Yes, I5 and I12 both are similar item set, but locates are different. So let us give a number as a 5. 512, then I7 I13, where is 7 is here and 13 is here, so it is reducing the star dot only. Here also star dot only, so lookets are different. The next one is a I8 and I10, so let us give name as a I810. So these things we must be apply before enter to the LALR. Okay, so these you must be remember the who are the common production or item sets and with the different lookets, and 411, 512, 713 and 810. Okay, so let us go to the table now. So now this is actual table for the CLR. Now who are common? We already identified that 4 and 11 are common. So let us give a name for every 4 as a 411. So wherever you see the 4 and 11, you must be convert that name as a 411. Here also you need to apply 411 and here 411. That's it. So then I think so whenever you go to the S4, you also convert this S4 into the 411. So wherever you see the 4 and 11, you must be put name as a 411, but don't put the 411 or the combination and new name for the reduced states. But you already know that reduced states are predefined, which are given to the grammar production, so no need to apply for only reduced states. Irrespective of that reduced states, you can change the name anywhere, but don't apply that new names to the reduces, because reduce are numbers for the productions. Reduce number 1, reduce number 2, reduce number 3, 4, they are given to the production of your grammar. So no need to, because we don't see the some 411 production number anywhere. 411 production number, nothing but 411 production number we cannot say. We know that R4 production, R4, that production is reducing here. So don't give the new name to the reduces. You must be give to the then go to operations and also for the shift operations, and also assign to the state number. Now let us apply 4. Now I4 state is become I411, and here also 11 state is become 411, and S4 here. Actually, what is the name? What is the name of this location? S4. Now you convert into the S411, and here also S4 and S411, S4. Wherever you see the 4 and 11, you write it as a 411, but don't give to the reduces. Except that you have to give anywhere it is occurred, you have to give. Then 1, 2, 3, and I think so. Next one is the 512 is common. Wherever you see the 5 and 2, 5, here S5, you must be give as a 512, and here you must be give as a 512. Wherever you see. Now where other locations like okay, that's it. Now 411 as well. Next 810. So 810. See here 8. And here also 10 and 10. So for every location of 8 and 10 combination, you convert into the 810, 810, 810, 810, and 713, you give as a 713. That's it. So after you change these names into the new name, then you have to apply the union. Now how to apply the union here? Can you see that I0 is one of the row, or it is a one I0 item set? Can you see anywhere it is I0 is repeated? No, not it is repeated. And I1 not repeated anywhere, I2 not repeated anywhere, I3 not repeated, but I411 is repeating here also. The same, there is a one name we have given to the one row, but that value is repeated 2 number of times, so we need to apply the union. So whenever you see such kind, because obviously we have given, so this is a way to apply the union. Now you have to apply the union or apply the merge between 411. Now here see S512. After you are combine these two values, can it is affect any another new value? No, it is not affecting, because 512 here also 512. We can apply the union. Now 512, single 512 will be get, and again S41. And here also S411. So whenever you are apply the union, nothing will be effect. Now come to this point, 810 and 810. You are merging the two rows into the single row, but after you apply even the merge or union, the value could not be affected. In case, what do you mean by the effect here? In case, let us consider there is some reduced state. There is some reduced state like R1. If I apply the merge operation, then you will get the shift reduce conflict. because it's a 512, okay, but shift to 411 cannot merge with the some reduced number, so this is called as a conflict. So whenever you get this such kind of conflict, then you can say that that grammar is not a LALR. Okay, so these are things we must be remember. Now for this grammar you may not be get the conflict. I'm just given you one example that how the conflicts are going to be occur. Now like 411 is has been measured to the single row. Next one 5. Next who is the next one? 512. Now 512, see the first on ID it is empty, but 12 already empty, and here it is R4. Okay, empty with R4 nothing will happen. Empty with empty nothing will happen. You can merge one by one. Next R4 and empty now. So finally 512 will get R1 and R4. So there is no conflict. Now next one is I6. Obviously there is no change in I6. Next one 713 is a union. We need to apply. 713 is repeating here and here. We need to apply the union. Now you apply. So R3 empty, you will get single R3, and empty with empty you will get empty slot. And now R3 and R3 both are similar reduces, so you will get same value. Then you can apply here. Now 810 similar way, 810, 8 here complete empty, 10 also empty. Eight 10 sorry 8 here it is 10, R5 empty empty, R5 R5. So finally you will get this table. This table is called as a LALR table. Okay, so this is a CLR table. We are applying some rules on the CLR table, then finally you are getting the LALR table. LALR states are maybe less than or equal to the CLR table, and you also remember that CLR is a more powerful than LALR.